Assalamu alaikum and a very good morning to the respected judges. Welcome to the International Innovation and Entrepreneurship Challenge, iIEC, 2026. My name is Ibrahim Al-Rashidi Mohd Fawzi, the inventor of this project, and I am supervised by Technologies. Dr. Noorhanani Abed Rahman from the Department of Electrical Engineering, Polytechnic Port Dickson. Today, I am honored to present our innovation, Interactive Sensory Wall using LED technology to support inclusive learning, Product ID TLP 053. Inclusive education requires learning environments that can accommodate students with different learning abilities. However, students with ASD and ADHD are highly sensitive to sensory stimuli such as light, sound, and touch. Excessive sensory stimulation often causes stress, poor concentration, and behavioral challenges. Another issue is that many classrooms do not have appropriate sensory support tools. Existing sensory systems are often expensive, bulky, and difficult to implement in schools. Therefore, we developed the Interactive Sensory Wall, which is low cost, safe, energy efficient, and easy to use in classrooms. This project addresses four main issues in inclusive classrooms. First, students with ASD and ADHD are highly sensitive to sensory stimuli, which can reduce their focus and emotional regulation. Second, conventional classrooms often lack a sensory-friendly learning environment. Third, the sensory support tools currently available are expensive and complex for schools. Finally, there is a lack of affordable and accessible assistive technology. Therefore, we developed the Interactive Sensory Wall as a low-cost, safe, and interactive solution to support inclusive learning. This project has three objectives. First, to design and develop an interactive sensory wall using Arduino, touch sensors, and RGB LED strips. Second, to evaluate the technical performance of the system in terms of response time, stability, and energy efficiency. Finally, to assess its usability and effectiveness in supporting engagement among PPKI students. The system consists of three main components: touch sensors, an Arduino microcontroller, and RGB LED strips. When a student touches the sensor, the Arduino processes the input and immediately activates the corresponding LED pattern. If there is no interaction, the LEDs automatically switch off to save energy. The prototype measures 60 by 40 centimeters and was designed to be safe, portable, and low cost. The evaluation consisted of two phases: technical performance testing and classroom evaluation at Sekolah Kebangsaan Taman Intan Perdana involving PPKI students and teacher feedback. The technical evaluation showed excellent performance. The average touch response time was only 86.5 milliseconds, demonstrating fast and responsive interaction. The LEDs remained stable without flickering or overheating, while the automatic shut-off function improved energy efficiency. For classroom evaluation, teachers reported that the system was easy to operate and required minimal technical assistance. Students interacted independently with the sensory wall, and the immediate LED response helped maintain their attention and engagement. Teachers also agreed that the product is safe, practical, and suitable for students with different learning abilities. Overall, the results confirm that the Interactive Sensory Wall effectively supports inclusive learning. Our innovation offers several advantages. It provides real-time touch-responsive visual feedback, uses a modular design, and is safe, low-cost, and energy efficient. The prototype costs only about Rm150 to build. For commercialization, the initial target market includes 151 PPKI schools in Negeri Sembilan, comprising 97 primary and 54 secondary schools. The product can also be expanded to therapy centers and rehabilitation facilities. Next, let me demonstrate how the Interactive Sensory Wall operates. First, the system is powered on and takes a few seconds to initialize. When a student touches one of the capacitive touch sensors, the Arduino microcontroller immediately detects and processes the input. The corresponding RGB LED pattern lights up instantly, providing visual sensory feedback that encourages interaction, attention, and engagement. If the student continues touching different sensors, different LED patterns are activated, creating an interactive sensory experience. When no touch is detected for a preset period, the LEDs automatically switch off to save energy. Overall, the operation is simple, safe, responsive, and suitable for students with different learning abilities. In conclusion, the interactive sensory wall is an innovative and cost-effective assistive learning tool. It enhances student engagement, sensory stimulation, and supports inclusive education. Its affordable design and strong commercial potential make it suitable for wider implementation in schools and therapy centers. The project has also received recognition by winning a gold medal, Best Project in Diploma Electronic Engineering, Communication, and third place overall at the Electrical Student Innovation Exhibition 2025. Thank you for your attention. We hope the interactive sensory wall can contribute to creating a more inclusive and engaging learning environment.